My focus is going to be on cooperation. And I find cooperation really interesting to study because on the one hand, cooperation is totally essential for basically everything in life, from the cells in our body to our personal relationships, our professional relationships, management of organizations, and global level issues like conservation and climate change. What all these things have in common is that they're positively non-zero sum, which is to say everybody's better off if everyone cooperates, but at the same time, they're challenging because they require individuals to bear personal costs in order to create those benefits for others. So both from the perspective of evolution and classical economic models of self-interest, it makes cooperation surprising. And so the key question that I'm interested in is, why do people cooperate? And for the purposes of today's talk, I'm going to think about that question from a dual process perspective, which, as we heard in the earlier talks in this session, involves thinking about two different ways of making decisions. On the one hand, you have careful deliberation that's paying attention to the details, and throughout this talk, I'm going to represent deliberation by my son Isaac, who was, when he was 1 hour old, was carefully considering the world in which he found himself. And this is the way, sort of standard decision-making models work. But the idea of the dual process theories is that there's also sometimes you make decisions not by carefully deliberating, but by going with more automatic, intuitive processes, which are going to be represented by Isaac's identical twin brother Miles, that was not paying as much attention. And I think a theme that came up in the earlier talks is that there's a lot of different ways that you can conceptualize dual process models. And for me, the key idea is the trade-off between the flexibility of deliberation and the ease of intuition. So deliberative processes are cognitively effortful but flexible. Intuitive processes are less effortful but also less flexible. Okay, and so in the context of cooperation, the question is then, is the way that cooperation happens that we use deliberation to override selfish impulses, so deliberating is the hero of cooperation, or do we have an intuitive predisposition towards cooperation, which then gets overruled by the calculus of self-interest, in which case intuition is the sort of hero of cooperation. And so the idea is which of these is correct, and lots of people have their own ideas about it, and there's lots of lay theories about it, but I want to start from a sort of principled theoretical perspective of asking what should we expect the case to be. And so toward this end, we made a formal computational model, which is a sort of game theory model. And I'm not going to talk about it in detail, but I'm going to summarize the results, or summarize the model. So the idea is sometimes we have interactions that are like what's modeled by a prisoner's dilemma. You have a chance to help another person, and that's it. It's like a sort of one-shot anonymous thing. So no matter what, it's always in your self-interest to defect. And so this is what I'm going to call pure cooperation. It's sort of altruistic to cooperate in this setting. But a lot of the time, and I would argue, in fact, most of the time, our situations aren't like this, but instead, they're situations where you have future consequences, such that if I cooperate with you today, it makes you or someone else more likely to cooperate with me in the future. And the key idea here is that means that it can be payoff maximizing to cooperate today in order to earn cooperation in the future. And so that means here cooperation is strategic. And so if you have agents sometimes engaging in pure cooperation settings, sometimes confronting strategic cooperation settings, the way that I think about the dual process element is we say that agents have the option to pay a cost in order to tailor their decision to the type of strategy, to the type of interaction that they're facing. So they can say, what do I want to do if it's pure? What do I want to do if it's strategic? Or they can rely on an intuitive response that they don't have to pay a cost for, but can't condition on gain type, and just has to say cooperate or defect regardless of which type of game it is. And so what we do in this paper is we analyze this model and ask, what are the winning strategies, both from a sort of Nash equilibrium perspective and also from an evolutionary perspective. And what you see as the winning strategy in situations where these sort of future consequences are common is the strategy that is what I've talked about elsewhere in the context of a social heuristics idea. And so the strategy says, because most games are repeated, and that means it's typically a good idea to cooperate, you should adopt as your intuitive option cooperating. Then if you deliberate and you realize it is in fact a future consequence. You say, yes, that's good, I stick with my intuition. But when you find yourself in the less common one-off sort of social dilemma, pure cooperation settings, there, if you deliberate, you should overrule your predisposition to cooperate and switch to defecting. And so this idea, which essentially is saying that you you internalize the typically advantageous behavior as a social heuristic, makes some clear testable predictions. The first one is that when you're in the context of a pure cooperation setting, intuition should favor cooperation, and deliberation should undermine cooperation, because deliberation should shift you towards the behavior that's payoff maximizing here, which is defecting. Whereas if you're in a strategic cooperation setting, then when you deliberate, deliberation should support the intuition to cooperate, because you say, oh yes, the intuition was right. This is one of those situations where it's good to cooperate. And so what I'm going to do for the rest of the talk is present a meta-analysis that I did recently testing these predictions. And specifically what you get out of these predictions, I should say, is that if you experimentally manipulate the use of deliberation versus intuition, you should have different outcomes in these two contexts. Making people less deliberative should increase cooperation in the sort of pure altruistic settings, but it shouldn't in the strategic settings. Okay, so I'm going to start with the prediction about pure cooperation. For this meta-analysis, I found 51 studies with over 15,000 participants that met the following two criteria. First, they involved subjects paying material costs in order to give material benefits to others. And specifically, it was in settings where there was no strategic or self-interested reason to pay those costs. So this was one-shot public goods games, one-shot prisoner's dilemmas, and player 2 in one-shot trust games, deciding how much to return. So that was one criteria, is there had to be actual monetary cooperation decisions that didn't have a strategic element. And the other criteria is that the use of intuition versus deliberation had to have been experimentally manipulated. I didn't use correlational studies looking at reaction time correlations or other things. We really want causality, so we're just looking at experimental studies. And there was 4 different flavors of these that I included. There are time constraint studies, so studies where people are put under time pressure or asked to, or like forced to stop and think before they decide. There's cognitive load studies, where people are asked to do a cognitively more or less demanding task at the same time they're making their choice, where the more demanding task makes them rely less on deliberation for the cooperation choice. Ego depletion, which is basically the same thing, but the more or less demanding task happens beforehand. And then intuition inductions, which could be of the form of just straightforwardly asking people, please decide using intuition, or please carefully think about it, or things that are a little bit more subtle, like recall inductions, having people write about a time in their life where they used their intuition and it worked out well, or where they carefully deliberated and it worked out well. And I didn't include time constraint studies where the time pressure was applied to the instructions or the information about the payoffs, because I was interested in looking at how these manipulations address decision making, not addressed understanding what decision you're making. Basically, this introduces a sort of attentional confound where the time pressure people might just not have understood the payoffs rather than actually sort of leading to different decisions. And also, a lot of these experiments included secondary manipulations where the intuition deliberation manipulation was crossed with something else, like the way the choices were framed, for example. And I didn't want to give myself researcher degrees of freedom of choosing which secondary manipulation conditions to include versus not, so I just said I'd take the conservative approach and just include everything, even though many of these secondary manipulations were expressly designed to get rid of an intuition deliberation effect. Okay, so this is the setup. Before I show you the results, I want to note that a big problem with meta-analyses that has been getting a lot of attention recently is when there's publication bias in the studies that go into the meta-analysis, you can't really put very much stock in what you get out of the meta-analysis. But happily, in this data set, there's not evidence of publication bias. This is true both in terms of small study effects, so there's no correlation between the size of the study and the size of the effect. That's bad if that happens, because that suggests if you're only getting big effects in small studies, you're in trouble. And there's also no evidence of p-hacking. So this is the distribution of p-values, and it's good that there's lots of small p-values, and it's good that there's not a big uptick in p-values right around 0.05. So, okay, no publication bias. So here are the results. This is one line for each of the 51 studies, and for each study, you're going to see the size of the intuition effect, which specifically it's the fraction of the endowment contributed on average in the more intuitive condition minus the amount contributed in the more deliberative condition. So positive values means intuition increased cooperation, negative values means deliberation increased cooperation. And so for each study, you're going to see an effect size, and you're also going to see a 95% confidence interval around that effect size, and then you'll see the overall effect. And the studies are just going to be sorted from smallest to biggest effect size. So here we go. What you see is there are a bunch of studies that find big positive effects of intuition. There are a bunch of studies that find sort of like not significant, but in the positive direction effects. There are a few studies that find negative but not significant differences. So this black line is 0, so all of these are overlapping with 0. And there's only one study that finds a significant negative effect, and I've subsequently seen more data from this lab that shows more positive effects. So I think that that was just random chance. And when you aggregate all of these together, the dotted line here shows the overall effect estimate, and this is the 95% confidence interval around it, which is very strongly positive. It's positive, and it's very strongly different than 0. And it's a meaningful effect size. It's 6.1 percentage points, which translates into about 17% more cooperation in the intuitive conditions relative to the deliberative conditions. So that's the basic result. And I'll show you a few robustness checks. The first one is that in this analysis, I took the standard approach of excluding participants that failed manipulation checks. But you can include them. So this is like an intention to treat analysis. So even the people that took too long in the time constraint conditions or whatever, you still get a significant positive effect. You can include the studies where time pressure is applied to the instructions. You still get a significant effect. And you can collapse all of the studies from each lab, so you only have one data point per lab, which is sort of saying different studies from the same lab aren't really independent. So you can do that, and it still works. So one other quick point, though, is that there was a bunch of different manipulations, and although overall you get a nice positive effect, there's actually evidence that time constraint manipulation, so time pressure versus time delay, works much less well than the other ones. So this is just the average effect size from the time pressure studies versus the other studies, and it's about twice as big for the other studies. And it gets even worse when you don't exclude people that failed the manipulation checks, and there the time pressure effect basically goes away. And there's a lot of reasons that the time constraint studies should work less, like the time pressure is only applied when you reach the decision screen, so people could have been deliberating as much as they wanted while they were reading the instructions. You can't force people to decide quickly, so like compliance is lower. That is, compliance is much worse than the time constraint studies, and you have to set the threshold right or it's not going to work. So this is just to say, bummer that the original studies on this were time pressure, because time pressure doesn't seem to work that well. Okay, so then the other prediction is about strategic cooperation. So this is situations where you're paying a cost to give a benefit to someone, but there's a possibility of future gain. So this is any kind of repeated games or player one in these games where the player two gets to respond. The key idea is here, it can actually be payoff maximizing to cooperate if the other person is also cooperative. And again, the prediction is that because there's a self-interested motive for cooperating, making people deliberate shouldn't make them cooperate less. So I have 16 studies, 2,000 participants that met this criteria. Again, intuition versus deliberation manipulated the same way as for the pure cooperation. And now I'm going to show you this same sort of summary slide. And what you see is, unlike pure cooperation, there's no overall effect of intuition versus deliberation on strategic cooperation. That's totally not significant. And if you do a meta-regression where you put strategic and pure cooperation studies together, the effect of promoting intuition is significantly bigger in the pure cooperation social dilemmas than it is in the strategic settings. So this sort of validates that empirical prediction. And in particular, if the theory is based on this cost flexibility trade-off, the idea being that the intuitive response is less sensitive to the details of the situation, that means that you should see a bigger difference between strategic and pure cooperation when you're deliberating, because deliberating is letting you adjust to the details. So to show you this, I'm just going to show you the average cooperation level across these 4 cells. And one note is I just had to scale ultimatum giving, so giving half in the ultimatum game is maximally cooperative, because that's the normative thing to do there. And as we saw, there's no difference in strategic cooperation between the more intuitive and more deliberative people. And as you would expect, when you go from strategic to pure, so when you take away a self-interested motive for cooperating, the deliberative people cooperate less. And then the critical point is that the intuitive people don't adjust as far. And so the reason there's more pure cooperation for the intuitive subjects relative to the deliberative subjects is that they didn't adjust as far to the strategic details that they're facing. So to summarize, I'm thinking about intuition as an easy and fast but inflexible process. And that means that intuition should be shaped by typical interactions, or should be optimal for typical interactions, whereas deliberation can lead to what's sort of optimal in the specific situation that you're facing. And for our subjects, who are mostly Western, a lot of them college students coming from good environments where it's typically a good idea to cooperate, intuition favors cooperation. And then deliberating undermines pure cooperation, but doesn't undermine strategic cooperation, which provides evidence that really what deliberation is doing is shifting in the direction of self-interest. So thanks very much. Questions? Mm-hmm.
So I know that in meta-analysis we typically think about the file drawer, you did, but you made sort of estimates based on the data you did have of what might be out there. But since many of the studies in the list were your own, what's in your file drawer? And is it big or little? And does it give us?
Yeah. So to clarify, it's not that I did adjustments based on what was or wasn't there, but I sent out email to all the different lists soliciting unpublished studies. And so a good chunk of the studies in the meta-analysis were unpublished, including all of my file drawer. And actually, I already did a 2014 paper where I put my whole file drawer in a personal meta-analysis. So it's right. So it's not basically my feeling about the publication bias thing is the tools for correcting for publication bias are not great, but the tools for assessing whether it's there or not are pretty reasonable. So if you get enough data in the first place that you don't have evidence of bias, then you feel pretty good. But if not, then you're in trouble. So, yeah.